Welcome to this College Algebra training video all about transformations of graphs. You are already very familiar with these different types of functions from a previous video, but today we're going to talk about how to know the equation of a graph based on how the graph has changed from what is called the parent function. So parent functions are the most basic equation of that function. Nothing has been added or subtracted or multiplied. It's just that function. So for example, y equals x is the most basic linear function, right? It has a slope of 1. It doesn't have a y-intercept other than 0, and the x-intercept is also 0. But when you add the m, the slope can change. It can be positive, negative, it could be a fraction. And you add the b, and it moves it up, right? It's a vertical shift up or down, but just along the y-axis, so it's the y-intercept. You'll notice on all these other transformation equations that they have all of them in A multiplied at the beginning, H, which is always subtracted and it's always inside with the X. Maybe it's inside parentheses or in an exponent or inside of a logarithm. And the K is always by itself and just added at the end. So we're going to talk today about what the A, the H, and the K can do. We're going to go ahead and look at some graphs. We're going to use Desmos. Let me move this back to 0. All right, so here is our parent function, y equals the absolute value of x. I'm going to do some annotating as we write these equations. So let's first look at k. If I have the absolute value of x, I'm not changing anything in there, but I'm going to add 2. Let's see, k is 2. Let's see what happens. Type that in. K is 2. It has shifted up 2 along the y-axis. What if k was negative 2? It shifts it down. If you want to see all of the possible k's from negative 10 to 10, here they are. It just moves them along the y-axis. Doesn't change the shape or move along the x-axis, just along the y. All right, let's try some with k. So it's with h. So let's move k back to 0 and h. So if I write this in, let's say, oops, gotta annotate again. So y equals the absolute value of x. Here, h, let's say h is 3. So if I plug that in for x minus h, that would be minus positive 3. Okay, so in the equation itself, it looks like a negative 3, but let's see what happens when we type it in. Positive 3 moves it to the right 3. So even though it looks like a negative 3 in the equation, it moves it still to the right 3. Let's say if it was negative 3, our equation would then be the absolute value of x plus 3, right? Because it'd be minus negative, but it still moves it to the negative. So we'll move it opposite to the way that it looks in the equation. All right, let's look at A. Let's move this back to 0. And look at A. So A right now is at 1. So it's just y equals the absolute value, y equals 1 times the absolute value of x. That's where it's at right now. But let's look if we were to change it to the absolute value of x. So we're just going to say A equals 2 and see what happens. Type that in. A equals 2. So our graph has become skinnier. It's squished. It's stretched up. This is called a vertical stretch. So it's where it used to be at 1, 1, now it's at 1, 2. It's taken all those y values and multiplied them by 2. Let's see what happens if we have a negative a value. Oh, it has flipped it over the x-axis, and now it is an upside down v. Let's go ahead and look at if I had changed multiple things in the equation. So let's say, I'm going to write again. Y equals negative 2 absolute value of x minus 1 plus 3. Okay, so the -2, the negative is going to flip it down. The 2 is going to stretch it. And we're going to have absolute value of x minus 1. So it's going to go to the right one, right? Because it's minus, it's going to do the opposite. And up 3. Let's see what happens. Stop drawing. A is 3. H is 1. And A is -2. So it is now shifted to the right 1, up 3, flipped over to be an upside down V, and it is skinnier. It has a vertical stretch 2. Let's see what happens if I have a fraction. We didn't look at that with A yet. So plug that in. What if it was 0.2? Whoa, 0.22. It is squished now. It's a lot flatter, right? That's called a vertical compression. It's been compressed. Somebody sat on it. That's how I think about it. And so whenever you have a fraction A, it's going to be a lot less steep, but a bigger than 1A is going to be steeper. Okay, let's just look at some other functions just to see if they act the same way. Let's clear my drawings real quick and go back to Desmos. Stop editing. Okay. Let's look at how this acts in a quadratic function. All right, so K, we think moves it up and down, right? Let's go ahead and turn on our parent function dots. So let's say K is 3. Yep, moves it up and down. Up and down. We were right on that, all right? H moves it left and right, opposite the way that it looks in the equation. So if it has x minus 2 squared, it's going to look like this. It'll move it to the right 2 still. And A, oh, let's go back to 0. A, let's say this is -1. Yep, flips it down. -5. Oh, yep, skinnier. Let's do a fraction, 0.8. A little bit flatter. Right? One thing I want to point out with absolute value and with quadratic functions, the H and K tell us the vertex, which is either the highest point or the lowest point. So for example, in this one, and with the absolute value ones we're just talking about, if I have 3 is my K and -4, then notice my vertex is at -4, 3, my lowest point on the parabola. Well, yeah, let's just look at a few more for fun, but I think we're getting the idea of what H and K and A do. Let's do square root. All right, K and H. Let's just play this. It'll be fun. Oh, let's turn on this. Oh, I already changed it to 2.5. I forgot about that. Whee! I just think so. Oh, can we play them all at the same time? Oh, yeah. Where is it going? Hey, what's it doing now? Okay, I'm having too much fun with this. Let's turn off H and K. Set those back to 0, and let's just look at what A is doing for this one. Okay, so we're still at 0, 0 as our endpoint. And let's go ahead and pause it right there. So bigger than 1 is going to stretch it, vertical stretch still. Less than 1, I'm too slow, man. Let's say 0.5. Okay, vertical compression. It's been squished, and negative flips it along. Okay, this is also going to be true for exponential, for logarithms. Let's go ahead and head back to the PowerPoint and do a little summary. All right. So A, the A number at the beginning of the function tells us how steep it is, right? If it's been stretched or compressed. It also tells us if it's been reflected over the x-axis to shift down to be an upside down V or an upside down U. So if the absolute value is greater than 1, meaning it's farther away from 0 than 1, so -5, +5, both fall in this category, it's going to be steeper, right? We saw with the parabola, it went from being this to being this, right? It got steeper for those ones. Same thing with the other functions. If it is a fraction between 0 and 1 or between 0 and -1, it's going to be flatter. It's going to go from this to something like that, right? Still a smiley face, but just a steeper one. If it is negative, meaning less than 0, same thing, it's going to reflect. It's going to go from this down over the x-axis. All right, that's A. H, remember, is horizontal shifts in the opposite direction. So if we have something like, let's do a logarithm. We haven't looked at that yet. Log base 2, x minus 3. That's going to shift positive 3 to the right. Here's how I remember it. H, opposite. I just really emphasize the beginning of that word, opposite. It's opposite of what it looks like in the equation. And K is a vertical shift in the same direction. I think about this one. K means keep the sign. Right? If it's positive, it's going to go up. If it's negative, it's going to go down. And one more thing to remember about that. For absolute value and quadratic functions, the only ones with vertices, whatever H is and whatever K is going to be the vertex. Okay, I want you to try one. I'm going to show you a graph, this graph here, and I want you to pause the video and write the equation of that graph. Okay, welcome back. Let's look at what happened. So it has been shifted to the right 5. So that's going to be the opposite in my equation. To the right 5. So minus 5, opposite. And this is a parabola, so it's going to be squared. It's going to add up 1. It's been shifted up 1. It's also been flipped. And it looks like it's been sat on a little bit. It's been compressed. And so if I look at it from, this is like my vertex, right? If I go over 2, it's now, whoops, over 2, it's at 1. Interesting. Right? So if you think about 2 squared, that would normally be 4. Right? If I go over 2 on the normal one, it goes up to 4. And so the y values have been cut by 4. They've been divided by 4. So this is 1/4. Right? If you do any more, if I go over 4, it should be at 16, but it's only at 4 away from where I was. And so it's been cut into 4. So let's see if I was right. Yeah. All right, that is transformations. Go ahead and do the assignment on this if you haven't already. Good luck.